Welcome to the session on cloud computing and its application. So in this particular session or in this particular video, we will talk about different technologies. In this video, we are going to talk about Xen, Xen-paravirtualization. It's a type 1 hypervisor providing services that allows multiple computer operating system to execute on the same computer hardware concurrently. It was originally developed by University of Cambridge Computer Laboratory and is now developed by Linux Foundation with the support of Intel. Xen is an open source hypervisor based on paravirtualization. It is the most popular applications of paravirtualization. Xen has been extended to compatible with full virtualization using hardware assisted virtualization. It enables high performance to execute guest operating systems. This is probably done by removing the performance loss while executing the instruction, requiring sufficient handling, and by modifying portion of guest OS executed by Xen with reference to execution of such instructions. Hence, support x86, which is most used architecture and commodity machine and servers. So basically Xen was originated as a project of a research work by University of Cambridge, and the first version was released in October 2003, and latest we have 4.13 version running, which was released in December 2019. Xen supports virtual machine live migration from one host to another, allowing workload balancing and avoiding downtime. So, in coming few slide, let us talk about Xen architecture and the guest OS management. Okay, the figure describes the Xen architecture and its mapping onto classic x86 privileged model. A Xen-based system is handled by Xen hypervisor, as we discussed, hypervisor 1, which is executed in the most privileged mode and maintains access of guest operating system to the basic hardware. Guest operating systems are run between domains, which represents virtual machine instance. In addition, particular control software which has privileged access to the host and handles all other guest OS runs in a special domain called domain 0. This the only one loaded once the virtual machine manager has fully booted and hosts an HTTP server that delivers request to virtual machine creation, configuration, and also termination. The components establish the primary version of shared virtual machine manager, which is necessary part of cloud computing system delivering infrastructure as service solution. x86 implementation supports four distinct security level term as ring, that is, as you see in the figure, that's ring 0, ring 1, ring 2, as well as ring 3. Here, ring 0 represents the levels having most privileged and ring 3 represents levels having least privilege. Almost all frequently used operating system except for that of OS2 uses only two levels of rings, that is ring 0 for kernel code and ring 3 for user application and non-privileged operating system. These provides a chance to Xen to implement para-virtualization. This enables Xen to control unchanged application binary interface, or we also call it as ABI, thus allowing a simple shift in Xen virtualization solution from an application point of view. Due to the structure of x86 instruction set, some instructions allows code execution in ring 3 to switch to ring 0, that is a kernel mode. Such an operation is done at hardware level and hence between virtualization environment. This condition is basically occurred by subset of system calls. To eliminate this situation, implementation in operating system requires modification and all sensitive system calls needs re-implementation with hypercalls. Here, hypercalls are particular calls revealed by VM interface of Xen and uses of it. Hypervisor tends to catch the execution of sensitive instruction, manages them and returns the controls to guest operating system with the help of supplied handlers. Paravirtualization demands OS code base to be changed and hence all operating systems can not be referred as guest OS in Xen based environment. Uh, in fact, these are not possible to modify to run in ring 1 safely as their code base is not reachable and concurrently the primary hardware hasn't any support to execute in the most privileged mode, that is ring 0. As we discussed, guest operating systems are run between domain which represents a virtual machine instance. We have already discussed this in the previous slide. There are basically different types. In this slide we have listed a couple of types of Xen virtualization. So there are 5 approaches for running a guest operating system. One is hardware virtual machine and one is hardware virtual machine with para virtualization driver, that is HMV with PV driver. We have para virtualization with full hardware virtualization, and we have PV in hardware virtualization container as well as a para virtualization. So let us not talk about these in depth, but these are different 5 approaches for running Xen. So here we have discussed basics about Xen para virtualization, one of the technologies for virtualization with different levels of its privilege modes starting from ring 0 to ring. This gives you a short explanation about Xen para virtualization. In the next section or in the next video, we will talk about VMware, which is a type of full virtualization technique. Thank you.